to data. Well, hopefully this is exciting for you. We're going to talk a little bit about data. And I sort of talked about this last time. One of the reasons I really wanted to do this workshop is because there's a lot of misleading information out there. When people misuse data, they show you something that seems to be really cool or seems to be telling you something when it's really not doing actually anything except for being funny. So these are the things I want to talk about. I want to talk about how to use data, how data is different. And these are the basic things you want to think about when you're dealing with graphing. Especially long versus wide form data is very important when it comes to graphing when you're specifying aesthetics. And we'll talk about why. How to use data. So, you know, I already said that. For the purpose of this workshop, though, what I'll talk about is the first thing we want to talk about is the structure of data. Now, this workshop is actually pretty short. We'll talk about the structure of data, talk about the different graphs you can have. We'll talk about exploratory analysis versus causality or causal analysis. All right. So the first thing I want to talk about is the structure of a data. So you'll be able to find this data set. You'll be able to use this code to download the data set that I uploaded. It's called workshop data 2. So right now I just called it data. By the way, this is like a really bad way to name your data, but for some reason I just got really used to it. So I always name my data 1, data 2. It's a really bad way. Do not replicate this as long as you don't have a habit of it already. Do not replicate this. Okay. So data structure, long versus wide. Now remember when we looked at the data frame, it's like an Excel sheet, right? A data frame. And each column is a variable, or we call attributes. Each column is a variable or attribute that tells you something about each row, right? So well, if we have, say, this data set it tells you when they submitted, it tells you whether they want to attend the workshop, and it tells you a bunch of other stuff. Right? Tell you their age, stuff like that, and what days they're available. Okay. Which means, and this is the language I'm going to use now, is each row is an observation. But if I have the same dimension, now notice the air quotes here, the same dimension of data. Say the days I'm available. I have days as Monday, Tuesday, Wednesday. Okay, this is the same dimension. But I can separate it out to be, am I available on Monday? Am I available on Tuesday? Am I available on Wednesday? Right? So now this became 3 dimensions, even though it's really 1 dimension of data, but it became 3 attributes. Okay? I call these levels of attributes, these different attributes, I call them instances in this workshop. I'll just call them instances. And each unique person, each unique observation would be observations. Just to kind of get the language straight here. Right? We have that. We have observations and we have instances of data. Right? So when I look at workshop, this is an instance, yes. Right? And when you actually load data 2, which I probably should if I'm going to use it. Okay. So remember, you just literally copy this and just load it. As long as you have ggplot loaded. Okay, so I loaded my data. And now my data looks like this. Okay, so what you'll see is instead of having bad as the least favorite weeks of each person's like perspectives classes, I have bad 1, bad 2, bad 3, so they can have as many as 9 least favorite weeks, which will be, you know, practically useless, but you know, that's possible by the design of the data. So now for bad, I have I have many instances because after that there's bad 3, bad 4, bad 5, bad 6, all the way through bad 9. I have 9 instances of this attribute, but there are also like 9 bad attribute. But you can also see there's good, that's just 1 long one instead of being many attributes, right? In this case, what I would say is each observation in terms of bad, each observation has multiple instances. In terms of good, each observation has just one instance of good, but I have many observations that each contain per instance. I know it sounds really confusing. When we have data that's long, it means that I have many instances in one attribute instead of many instances over many attributes. So each row only has one instance when it has many instances. So you have many rows. If I have wide data, that means each row has multiple instances in it. Is that distinction clear? So when I was first learning about long versus wide, I never understood it. I literally learned it in junior year in econometrics, never understood it until this year, until I was using gather and spread, never understood it. So it's okay if you don't get a difference at first. And in the sense of a better example, which I probably should have put in here, and I thought about it, I just forgot to. Say we have all the math students' income before they came to maths and after they came to maths. A long form data would be, I said, Caroline's income in 2018, Caroline's income in 2019, Caroline's income in 2020. A wide form would be Caroline's income in 2018, 2019, 2020, right? It's wider. The long form is longer, so you have multiple instances. Well, you have one instance in each row. A wide form is you have multiple instances in the exact row, in the one row, right? Income vertically and income horizontally. Hopefully that makes more sense. Cool. To transform your data from long to wide, you take the column and you spread it. You spread it all over, right? So it's just called spread. To transform from wide into long, you grab these things, you gather these things into long. And that's what these functions are named. They're called spread and gather. And we'll discuss them in a bit. Just so you know, the newest version of spread and gather inside tidyverse is called pivot longer, pivot wider. As a person who learned spread and gather with much cost, I don't really feel like I needed to learn pivot longer or wider. So I never used it, but you could if you want to. I think it's like cleaner or something, but gather and spread works just fine for me most of the time. Oh, and also as a side note, before gather and spread is a thing, there's a set of function under the framework melt. I never understood how to use melt. I don't think most people understand how to use melt. So if you ever come across melt, maybe don't use it. I don't know. It's your choice. I would caution against it. Okay. So to do gather and spread, we have to understand key and value. So just think of key as like the names of things, right? So when we looked at like maps people's income, the keys would be Caroline, Hal, Tatiana, Willie, blah, blah, blah. And the values would be the incomes. Which means when I take the key and I say spread key and the value, key is names, value is income, I spread the incomes per person, right? So R knows like which attributes belong to the same person or which instances belong to the same observation and which doesn't. Okay, so we can see the column good here and the column bad, 1 through 9. The variables, the attributes will store your information, and then you have like a key kind of to tell you what's going on. Right, so we can look at per timestamp. So now you can see per timestamp, you could find, this random draw is not that great, but basically you should be able to find some that have like the same time but different good. It's because for each person, there could be multiple instances of good. Any questions? Any confusion? All right. So we have that. And then if we look at, oh, I thought I gave bad. Okay, let's look at what bad looks like. Data. Oh, I hope this works. Yep. Okay. So you can see this is how people say bad, right? You have multiple instances in the same row, right? This person hates psychology and sociology week, but the others are just NAs. Right? This person hated most weeks for some reason. So apparently they only like 2 weeks. This must be an economist. For your reference, personally, I only selected psychology because I hated that week, but everything else was fine. Anyways, so this is what it looks like. Multiple instances in one row compared to good, where you just have one instance per row. Right, so this is long, this is wide. Right. So now you kind of know what key and values are. We can look at gather and spread. So under the tidyverse package, you have the function gather, you have the function spread. Kind of talked about it. The general call is gather key equals to a string. This is supposed to say string, not sting. Key is string, value is another string, and the columns you want to spread. Right, you could have multiple things that you want to spread. Sorry, I mean gather. You have multiple things that you want to gather. And actually, this is miswritten. In spread, you're not going to spread columns. You're only going to spread the value thing that you wanted. Wait, no, that's not right. No, you spread columns too. Sorry, I got confused for some reason. In my head, it didn't work well. So in gather, you say, okay, I have all this information, and I'll gather it and put it into one column. In spread, you say, I have key, which is the individual observation. I have values, which is like the things you're trying to use. So say like when we're talking about like your income, you have the year 2018, 2019, 2020, right? That's going to be your value column in spread. And what it will do is it'll take this and then it spreads these columns. You pick the column you want and you spread it. So it says originally it's year, income. And when you spread it, it becomes income 2018, income 2019, income 2020, and it puts the values of your income. And that comes from columns. Okay, I can see why people change to pivot wider and pivot longer because it's less confusing probably. It's okay. When it doesn't work, you just like keep trying to figure out what works. Anyways, these are very useful. So for example, we can look at this. I said originally I have the data. I want to gather all these bads. I want to gather them. The key I'm going to use is bad, which means when I gather it, these names will be under the variable or the attribute bad. And bad week as my values or as my value, which means these information will be stored under bad week. And bad 1 through bad 9 are the columns. Are the columns that I want to gather. Now notice that there's a lot of NAs here, which means when I gather, I'm going to get a lot of NAs, which is why here I filter out NA. And you'll learn what this is next time we have a workshop on tidyverse. So I filter them, and I just want to look at bad and bad week, and I just want to look at 10 rows. So what this will give me is a data frame, right? Like time span, whatever, like I didn't show them. I just picked these two columns. I have bad, and these are like the different bads that I can have, and what the content of these bads are. Does that make sense?
Sorry, Willie. Is there any order in there?
So no. So what happened is if you wanted to order it, and this gets really, really complicated. But if you want to order it, you need them to be in a factor, right?
Yep.
Which means if you needed to order it, what you need to do is to, instead of looking at this bad, you have to create a new thing that uses the order by bad week per every person. And we'll talk about how to use group by when we talk about tidyverse. But you'll have to do that by person, and then you can get an order because this becomes a factor. Then you can spread it again so you can get the same name for every person to see whether it's there. Are you asking this because of your patent stuff? Because Alvin talked to me about it.
No, it's not like that. We actually figured it out.
Okay. Yeah, I told him, I can't remember what the solution was that I told him, but I told him something that should be very efficient. Anyways, so that's what it is. Okay, on the other hand, we can look at spread. We can spread good. So here I created a new variable just called number or num, and I can say spread using key num value is good, separate, and then it'll like spread the things I wanted to spread. So now it looks like this for everybody. But you'll end up with repeats because it's like the same thing. And I think if you can specify the column, it becomes a little different. I don't use spread that much, to be honest, so not that great at it. Take this with like a bucket of salt, if you will. All right, so after we talk about long and wide, remember long and wide is very important. And I just realized that in these graphs, I failed to acknowledge how important long and wide is with an example. I can talk about example at a different time where I actually had to like, so I was doing this homework where I'm graphing the effect of the policy and I have different effect and weights. Instead of graphing them as different attributes, I have to gather them into one attribute and graph by that so I can put them all under a color aesthetic so it separates it by color. Like these are times where you can just like do gather and spread to make it more creative so you can graph better. Remember, it's like when it comes to graphing, it's all about getting to what you want and not just settling for what you can get. Like whatever you can think of that made sense, probably you can graph it. You just have to figure out a way to make it work. There it is. So let's talk about different graphs. So earlier, like 20 minutes, 30 minutes ago, we talked about the geom functions that gives you different types of graphs. So we're going to talk about some basic graphs here. So first one is scatter plot versus jitter plot. So my code here is almost the same thing, right? I'm graphing the same set of data. And oh, I can't believe I didn't show you the code. Oops. I don't want that thing. How do I get rid of this thing? Yeah, this is why instructors get pissed because it's blocking my screen. It's blocking my screen. There we go. Okay, data. All right. So to create this graph, this is my code to create this graph, scatter versus jitter. Realize that because I need them to be two separate graphs but put together, what I needed to do is to only use half of the data for scatter and half of the data for jitter. Right? Again, it's all about how to make a graph that you want and just like manipulate it into it and not settle for what you can get. Okay, so I create a data set called plot and I give it a new column called jitter. I could create a new column called num and made these scatter. And I do the exact same thing for another data set, the same data set called, and then created a thing for jitter, and I just bind them together. So now I have duplicate of the same data set, but one attribute with scatter and the other one, the values are jitter, right? So when I'm graphing in my ggplot, I can say, okay, I want the plot data set, but only with scatter in it. And then I give it an aesthetic with age, characters, and the color aesthetic, right? So that gives me the color here. And I added geom point, which is what graphed out. Then I say, okay, I also want to graph a jitter plot. Looks like this. I want the same data set, but this time I only want the data set that is specified to be jitter instead of scatter. And then I give it the same aesthetics, and it plots a jitter plot for me. Now, this is where you can see what I was talking about. When I just do a scatter plot, all I see are these points, right? But I don't know how many actual points there are. I don't know how they're distributed. But when I use jitter, it doesn't give me the exact location of the points, but it gives me an idea of how dense that point is distributed, right? For example, if you look at this point versus this point, on the scatter plot, they look the same. But on jitter plot, you can tell one has less observation than the other. So that's kind of the difference between scatter and jitter. Now, this also means when you're using jitter plot, you're actually trying to look at how many observations are surrounded around that point. But which means if you don't have observations that are the same multiple times, you probably shouldn't use jitter just so you can actually get the location right. Does that make sense? Okay. The next is line plot versus smooth. Remember, line plot is where you just connect the lines, right? That's what I did. You connect the lines. Looks kind of like a heart EKG, even though it's not. But you can also smooth it over, right? When you do smooth under lowest, it just takes the average, like a local polynomial, and make this. Ooh.
Willie, I like that you think that that's what a heart EKG looks like.
I mean, it's not, but it also, at the same time, kind of is, right? Yeah.
It kind of is.
Yeah, kind of, not really. If somebody's EKG looks like this, they're probably about to die.
Yeah.
Honestly, this is not a good heart. Anyways, so this is a line versus smooth. And know that if I specify my smooth, right, this is my code. If I specify G on smooth, the method to be LM, what would happen? You just get a line, right? You just get a straight line. I hope I have the code for this. Let's see. I hope I loaded the data set for this. Method equals to LM. See, it's just one line. Right? That's the difference between line plot and a straight line plot. Okay. Next is histogram versus bar chart. Like I said, they're kind of like interchangeable in R. If you're prone to use data, the default Y characteristic for histogram is density. In R, the default is count. So here you can see your bar plot literally looks the same as histogram, except your bar plot has these like gaps between them for you to distinguish what's going on. Whereas histogram, what you care about is the distribution. So it's just merged together. Right? Technically in bar plot, you're looking at each category, each block category, and how much count there are.
Willie, for the bar chart, I guess, and also for the histogram, can you do like a color gradient on it as well?
Color gradient as in what? You always need a numeric. You always need a numeric thing to go into, or not necessarily always need a numeric thing, but you need an aesthetic for it to map the color, right? So it depends on what you're trying to map.
Okay. But it is, I mean, it would be possible to do it like certain levels, like up, or also like different colors.
I think so. So let's see. Let's run this first so I can get that graph. Okay. So if I want to specify a color, right, I can do, this is fill. So I can say scale, okay, I have scale fill here. Let's see. So I think this will be in Y. Scale Y continuous, because my Y is my count, and I want, actually, I'm not super sure. I know you can do it for sure. I'm pretty sure you can. But because histogram is in count, I wonder what would happen. So let's see. If I have a bar plot, Y is count. I think that's the call. Let's cancel this out first. See if this runs. Okay, so I run it. That means, but I need to give it a color aesthetic, right? So I can say color equals to count. You see, that's like on the border.
Yeah.
It's on the border, which means if I wanted to, I technically didn't have to specify this fill here, right? I can just call these counts. Also, when you're dealing with your own chunk, trying new things, don't just edit it, because then you might not be able to go back. You should copy it and paste it. I only did this just right now for convenience. Okay, so I can have this. What? Continuous value.
I think color has to be like.
Oh no, it's because of this. It's because I said scale fill discrete. So what I can say is scale fill continuous. I can change this to count. And then I can specify a palette. Actually, let's not use continuous. I personally like Brewer or just the other. Brewer. Palette is spectral. I think that's the name of it. Damn. Continuous values apply to a discrete scale. But fill is not a discrete cell. What happened? Just put it aside. See, this is what happens. It's like you're trying to do something and then you mess with your code and then it just all goes down. Ah, this is what happens. Spectral. Works. Nope. I'll deal with this later. But yes, you can.
Okay, sounds good.
You can. Not really sure how to do it at this moment. This should have run. I don't know why it's not running. Damn, now I'm getting bogged down on how to do this. Okay, I'm just gonna look away.
when things don't run, it doesn't like tell you where in the code there's something wrong.
It doesn't. Yeah, it doesn't. So what you need to do is to just kind of figure it out as you go. Like you literally, like sometimes what I would do is I would just, so like for example, if I think this is the one that's not working, I'll just comment it out.
Okay.
And try it again to see if it works. Ah, it worked. Right, I'll do that. And then let's see if this will work for me. Okay, or count. Okay, so it still doesn't work. Yeah, usually the error message tells you what's going on. Well-written packages should always tell you what's going on. Okay, so see how I have this?
So exciting.
Now, yes. Yeah, and then you can specify different. Like if I say red, oh, it didn't specify it, but you know the drill.
Yeah.
But that's kind of what's
Thank you.
going on. Yeah. I'll deal with recovering that later. Good question though. So histogram versus bar chart. Our next one is box plot versus density. So this one is strictly just giving you the kind of the distribution. So box plot tells you the distribution. The middle bar is your mean. Wait, no, median. Your median. And this is your. Wait, no, this is mean. How box plot middle is mean, right?
I can't remember.
I want to say yes because I know the top and the bottom bars are 75 and 25 percentile, which means this has to be mean to tell you like where the mean is distributed. Because you can find 50 percentile really easily, right?
Yeah, I guess so.
Or not. No. My bad. Box plot is median. Box plot, everything is median and percentile. So this is where 50 percentile is. What this means is most people are distributed around like 23 age-wise. And then you can see like outliers and stuff like right here, where you can also see it in your density plot. Okay. Now what you will realize is my Y has different scales. I have different scales in Y, right? This scale is for density, which is like 0.0 to 0.4. This is like the actual age, 0 to 40, how it's distributed. Yeah, so that's what this is doing. You can see here, I say scale Y continuous, and I specify a second axis for it. That's where this came from. And technically, you could run a reverse function. I don't remember the exact call right now, but you could reverse this box plot so it becomes horizontal if you want. So that's something you could do. Make sense?
Or like vertical, because it's already horizontal. Yes?
Yes. Well, I think of this as like vertical, and then you flip it to horizontal, but
It's
it's just
already
because of the
horizontal.
shape of the box. It depends on how you look at this plot. For me, this is vertical because the data are distributed vertically.
Oh, okay. Gotcha.
Right,
Okay.
and I can flip it to be horizontally distributed like this density plot.
Gotcha. Okay.
Cool. Hope that makes sense. If you have more questions about ggplot, I put a ggplot cheat sheet here that's written by our studio. You click on it. Oh, it just downloads it. But you'll be able to use it. It tells you like what everything is, how to use different things. Right? It's a very well written cheat sheet. I love it. It's really awesome. And this is way more than what I had taught today, but obviously I'm not gonna go over all this stuff.
And it has a little picture of Texas on it.
Yeah? Oh, really?
Yeah.
Texas?
I don't know.
It has
Yeah.
Texas? Where?
Oh,
This thing?
Yeah.
Under maps? Yeah, I guess. You could also do this under US Maps package, which is what is used in the homework that I assigned in ggplot 2. Fun stuff. Anyways. All right, next thing I want to talk about is analysis. This is the last thing in this workshop. So there's exploratory analysis and there's causal analysis. Exploratory analysis just means you're going to fit some model or graph something to try to get the underlying relationship, right? But this underlying relationship doesn't mean it's causal. It doesn't have to mean anything. Right? Remember our graph about age versus character count? I don't know where it is. Is it this one? Age versus, okay. Remember my graph up here about age versus character count? Okay, what does this mean? This doesn't actually tell me anything, right? This is just like, it's almost like, oh, your character count is like kind of fluctuating throughout age, but this is not going to tell you anything about anything. But I can show you this and make something up so you'll believe it, right? This is how misinformation misleads people, right? This is how it misleads people, because I can easily flip the axis here to have character count and age and say that people who have lower character counts are older. Or I can say it the other way. Like, I can make up things using this. I can just truncate this. What if I just truncate this data so it has this point and this point? And I can just say people who have very low character counts are just all old. Obviously, that's not true. Right? So it's really important that you understand that when you're doing exploratory analysis, or when you see a lot of these graphs online, most of the time it's only exploratory analysis, because all it does is show you this relationship that are numeric. It doesn't tell you anything. Now, it could be that there is underlying true relationship, but correlation is not causality, and you can see these things happen all the time. And it's important to distinguish that, oh, this graph doesn't actually mean anything. It's just a correlation. It's even just like random numbers that are generated. Right? So for example, if we graph precipitation, so the amount of rain, on y-axis, and the probability of you having your umbrella with you that day using historic data, I would get a very high correlation, right?
Yeah, definitely.
Does that mean every time you bring your umbrella out, it's gonna rain? No, you're not gonna cause rain, right? It's a signal. When you have your umbrella, it could be a signal that you think it's gonna rain. It could also be a signal that you had your umbrella in your backpack this whole time, you just forgot about taking it out. It could be anything. It's just spurious correlation. It doesn't actually tell you anything. And that's really important to know in today's day of age. And for more spurious and hilarious correlation, click on this website. It's called Spurious Correlations. It's really funny. I love this website, right? Like, this one is my favorite. This is the number of people who drowned by falling into a pool correlated with Nicolas Cage's films. You can see every year, you can see the correlation between Nicolas Cage films and people that drowned in the pool. Does that mean Nick Cage's film make people go into the pool and die? Possibly, but most likely not, right? That's not what it was. right? Cheese consumption and people being tangled in their bed sheets and died, very high correlation. Does that mean anything? Probably not. Anyways, you can find this website on the lecture notes slide. It's really funny. I really like it.
You know, they also got a poster of that in the econ department.
Oh, they did? I
Yeah,
didn't know that.
in the basement.
That's funny. Yeah. For your sociology people, non-commercial space launches versus sociology doctorates awarded in the US. Almost perfect correlation.
What is a non-commercial space launch?
Like if you
Is it
send
like
like
somebody
people,
in your backyard just like, hey, I'm gonna go to space?
No, I think it's like commercial space launch would be like Google launching a satellite. Non-commercial would be like American US Army launching a satellite.
Okay.
I still remember one with econ department that they collect the data of the height of the shift manager in the Fed and the interest rate, and they found a strong correlation.
I didn't find it here, but yeah, you can play around. The author of this website wrote a book, and you can buy it on Amazon. It's just like ridiculous. Anyways, so that's what exploratory analysis is. A lot of times you can get some underlying relationship to kind of guess, inform a hypothesis from it, but just be very careful what you're assuming. Causal analysis is what we try to do, right, as social scientists. Causal. It's very similar to exploratory analysis, but you have to have a lot of attention to logic and reasoning for the underlying relationship so you don't make like weird results come up. I'm obviously not going to talk about causal analysis in this workshop because it requires years of classes. The econ people take like at least probably 2 to 3 years of causal analysis classes just to know a little bit about how to do it. So, hopefully this kind of cleared up. Like when people see a lot of correlation online, they just assume that it's true without true relationship. It is not, and oftentimes it's laughable, but more often than not, it's very scary when people believe in that and use that information to take action. So that's kind of the reason why I want to talk about this. All right. So here you actually saw a lot of examples of how to graph things and how to write code. Personally, I would always say each function call has its own line, and when it gets too long, you want to separate them out like this. Really clean coding is very important when you're trying to, write readable code for yourself in the future to read. That's like pretty important. All right.
Well,
So that's the end. Yes.
Is it better to write your code in the console, or should you write it up at the top thing?
You should always write it in either your .r script, your .r markdown, or .notebook. Actually, sorry, .notebook is JPYMB for Python. Anyways, it's always better to write it up here, okay, because you save this thing. When you type something into the console, it's gone.
Okay.
Right, as long as you hit enter.
It's like a scratch piece of paper or something where you like work out what you're trying to do. Yeah.
I wouldn't think of it as like yes, you can use it as a scratch, but everything you type in here technically goes into the console. Oh. Console is where it actually interacts with the computer. But the thing is, when you tell the computer something, it's like words you said. You can't take it back, and you can't really figure out like what you said before. If you like exit a session and come back. But if you write this down in here, then you save it, you actually have the script that you can continue to recover and reuse, right? And I'll talk about why I love R Markdown and why a lot of people love R Markdown. It's just too awesome. Let me show you an example of, okay, so this is what I was using in my research. So I have my code all written down. This thing called data. This is a data set that has 54 million observations. It takes a very long time to just read it in. This entire chunk right here, takes about 45 to 55 minutes to run to finish outputting the data I want. Sometimes I fuck up my code, right? Sometimes I just really mess it up and I couldn't figure it out. So I go back here and read this, right? When you write things in the console, you kind of only have one line to look at. I mean, per RStudio, you can actually do many lines to look at it. but it's still far better to look at this and edit things as you go. Right, so I will always recommend using like markdown chunks so you can run things just by chunk. And even if I'm just testing things out, like I think when I wrote this chunk, I was just testing things out, right? So I just like writing a random stuff and then test it to see whether this code works or not. Yeah, and the thing I'm using, well, this is our notebook, but usually when I'm creating things, I have R Markdown. You can see, actually once you just see like HTML document or PDF document, you can specify other things. Right now, this thing outputs to a website, which is like the website you've been seeing. Personally, this is also how I wrote my cover letters. It's very lazy. So I have a cover letter R Markdown, which tells me how to write. Like, I have most of the like cover letter stuff as template already written, and I just change like small things. And all I need to change is this first block. I need to change which month it is, and then I wrote a code to just process it to give me like the exact date and year. Into this thing. I have the center, the university, the city, state, position in line, so what it writes in line, and then like the basic styling. So say I want to change it that, oh, it's July now, so I'm going to apply a job in July. I can just click knit. Now it says output PDF, so it gives me a PDF. That's my cover letter. I don't know how to make cover letter, right? And it says July 29th, 2020, and it does all this thing.
That is so cool. So you could
Yeah,
like do your resume by that too. I mean.
Oh yeah, easily. And I even wrote it so that if the professor part is NA, it says Dear Search Committee. If I write a professor name, it'll say Dear something something, right? So if I say Dear Caroline Leffert, right? I click knit, and it'll say Dear Professor Caroline Leffert.
That's so exciting.
Like that. Yeah. R Markdown is all about how to be lazy. I'm
a big fan of this thing.
It's really awesome. I don't like when we did perspectives, this is what I typed my lecture notes in. Like when we sat in those big auditorium, this is how I typed my lecture notes. Yeah.
I mean,
it's
what
really,
is the
really
output
convenient.
of that though? What is the output of that though?
I can show you. Sorry, you're getting a peek into my archival system. I can't find it. Oh, it's because
It's kind of small. I can't see it, so.
It's okay. That's good. Don't look at my archival system. So I have my notes, and say I have my notes on Foucault. Right, this is my notes on Foucault. Oh, this is really short. That's embarrassing. Let's look at Marx. Like Marx is like the last lecture I paid attention to. So
that was like
I wrote it like this.
Lecture.
Yeah, I gave up very early on. Okay, so this is like a bullet point, and these are like sub bullet points in our Markdown. You can write it, right? And then when I output it, it's very fast to type, and it gives me a PDF that looks like this.
Oh wow,
that's great.
I'll talk about our Markdown later. So I actually want to talk to you guys about this. I wanted to ask you this, and so right now you probably can see that my plan was to talk about next tidyverse, text data, and R Markdown, right? Yeah. So I think it would be kind of a push to actually finish all three. I mean, it might not be that much of a push. It depends on how much examples you guys want and stuff. But it could be a push. So potentially I could do a fourth workshop. And Hal talked to me today and asked me whether I would talk about how to web scrape using R. I could talk about web scrape, but if I want to, I will definitely have to add another workshop. So what do you guys think? I'm gonna seek some inputs.
I'm down for another workshop. This is very fun, so I'm in.
Okay. Yeah, I'll see. Well,
and also, I've like done minimal scraping with Python, but I've never done scraping with R, so I don't know.
Okay, I've only done scraping in R. It's really fun. I liked it. Yeah. So on my website, the menu part also includes all kinds of cheat sheet that you might need. So yeah, later on we'll talk about tidyverse text data and R Markdown automation. Okay, so another question I have for you guys is this. So if you go to the lecture notes, you'll see that the homework I assigned is really long, right? This one is about the ACS data. Oh, this is workshop data. What? Oh, under workshop data, ACS. Okay, this is ACS data. And there's a lot of cool things you can do in this. This is very carefully written, so you definitely should go through this. It's really fun. And this. Okay, so you can tell it's really long. So my thinking is, what if instead of having a workshop this Wednesday, we push it to next Monday? So you have more time to look at this, to learn from it, and then you can ask me more questions next week.
It's your workshop. You can do whatever, like, whatever scheduling works best for you.
Okay. I mean, I don't know how much you guys need to, how much time you guys need to like look at this. I also, obviously, I don't want to crowd out all of your time in like 2 days, right? So, okay, how about you guys try this, like do this, and then we push the workshop to next Monday at 10 instead of this Wednesday. Is that okay? Or is that contradictory to some people's times?
I'm okay with that.
Okay.
I'm fine with it. I don't know exactly how long this stuff is going to take.
Okay.
I've already planned to spend a whole afternoon for this.
Oh, really? Wow. Oh, I feel very flattered. Okay, yeah. So instead of having a workshop this Wednesday, let's just do next Monday.
Sure.
All right. It'll be really fun. I enjoy this thing a lot, and hopefully you can learn how to like do some cool graphing with this data set itself. And I highly encourage you to build like a project or something on your own to learn more. Right? Okay. Technically, that's like the end of this workshop. I'm gonna stop the recording now, so y'all can ask me more things.